A hidden superhighway threads the entire cosmos. It is not made of rock or gas, but of pure, electrified energy. These are plasma tunnels, vast magnetic structures that might be far more than cosmic scenery. By the end of this journey, you will understand how these filaments could redefine our place in the universe, offering a breathtaking vision of interconnected realities. We will explore how the aurora dancing above you is a tiny clue to a galaxy-spanning network, and we will confront the tantalizing possibility that these tunnels could be stable gateways. What forgotten truth about the cosmos are we on the verge of uncovering? These shimmering corridors are not cosmic mirages, but real structures with a name. We call them plasma tunnels, but in the textbooks you might find them described as magnetic flux ropes or Birkeland currents. At their core, they are exactly what they sound like: immense tubes of magnetized energy threading the darkness. To understand why they are so special, we first need to understand their primary ingredient, plasma itself. Plasma is often called the fourth state of matter, beyond solid, liquid, and gas. It is what you get when you heat a gas so intensely that its atoms break apart, creating a swirling soup of free electrons and atomic nuclei, all electrically charged. This sea of charged particles is then sculpted and guided by powerful magnetic fields. Now imagine taking that energetic, responsive substance and stretching it across the cosmos. Picture a river of lightning, not a few miles long, but millions of light years in length, flowing between galaxies and bridging the immense voids between them. That is the scale we are discussing. These are not the sudden, unstable wormholes of science fiction, blinking in and out of existence. They are persistent, observable features of our universe, woven into the fabric of space itself by fundamental forces. Their reality is what makes their potential so profoundly exciting. They are a part of the universe's established architecture, which means their secrets are written in a language of physics we are already beginning to decipher. This luminous network is the universe's true superstructure, a pattern so grand we call it the cosmic web. Picture the night sky not as a random scattering of stars, but as a single, immense tapestry. The brightest knots and clusters you see are galaxies, but they are not floating in isolation. They are strung like beads of light along invisible threads, connected across unimaginable distances by filaments of dark matter and hot gas. This is the cosmic web, the largest pattern of organization we have ever observed in nature. It is the scaffolding upon which the universe is built. Now, where do our plasma tunnels fit into this picture? Scientists theorize they are the luminous, energetic skeletons of this very web. They are the powerful, magnetized currents that flow along these cosmic filaments, giving them structure and perhaps even controlling the flow of matter and energy between galaxies. It is like discovering that the roads on a map are not just lines, but are actually glowing rivers of power, actively guiding the traffic of stars. Our evidence for this comes from both powerful computer simulations and real observations from space. Satellites like the Planck Observatory have mapped the faint, ancient light from the dawn of time, and within that signal, they have detected the subtle imprint of these vast, hot filaments. The data suggests the spaces between galaxy clusters are not empty voids, but are filled with a diffuse, superheated plasma, a thin but pervasive mist of charged particles. This means the cosmic web is not a static sculpture. It is a dynamic, interconnected network humming with energy. Every filament, every thread connecting one galaxy cluster to another could be a potential plasma tunnel, a superhighway of magnetized energy woven into the very fabric of space. The universe, it seems, is not a collection of isolated islands, but a single, breathing organism connected by rivers of fire. The shimmering aurora is not just a beautiful light show, it is a message. A century ago, a Norwegian scientist named Birkeland looked at those dancing green curtains and saw something everyone else had missed. he proposed a radical idea that the auroras were not caused by reflections of sunlight or some mysterious atmospheric gas, but by invisible rivers of charged particles flowing from the sun. These particles, he said, were captured and funneled down toward our planet's poles by Earth's own magnetic field, creating those brilliant displays where they collided with our atmosphere. He called these invisible rivers Birkeland currents. At the time, his theory was met with skepticism. How could something from 93 million miles away create such a localized, breathtaking effect? But Birkeland was right. Today, our satellites fly directly through these currents, measuring their flow and confirming his visionary work. So what does a phenomenon in our sky have to do with tunnels across the cosmos? Everything. The auroral currents wrapping around Earth are a perfect miniature laboratory version of the vast plasma filaments we suspect span the universe. They are the same fundamental process, just operating on a breathtakingly different scale. Studying how these currents form, how they remain stable, and how they transport energy right here in our celestial backyard gives us the rulebook for understanding the mightier versions. It is like learning the principles of a creek's current to eventually comprehend the powerful, continent-spanning flow of the Amazon River. The physics are the same, only the magnitude changes. So when we gaze up at the northern lights, we are not just seeing a pretty spectacle. We are witnessing a direct, tangible example of the universe's connective tissue, a small-scale demonstration of the forces that might be weaving galaxies together across the deepest voids. This earthly clue tells us those immense cosmic threads are not just theoretical, they are a natural extension of a process we can see and touch right above our heads. The northern lights offer more than a clue, they point toward a different way of seeing the cosmos entirely. For much of modern astronomy, gravity has been the undisputed architect of the universe, the sole force powerful enough to sculpt galaxies and pull them into clusters. But what if we have been missing half the blueprint? This is the core question of plasma cosmology, a perspective championed by Nobel laureate Hans Alfvén. He argued that while gravity builds the stage, electromagnetism writes the script. In this view, the universe is not a dark, silent void punctuated by isolated islands of matter. It is a vibrant, electrically active sea of plasma, where magnetic fields and electric currents are the primary sculptors of structure on the largest scales. This framework does not dismiss gravity but places it alongside a powerful partner. Imagine building a sandcastle. Gravity pulls the sand into a pile, giving it mass and shape. But to create intricate towers and bridges, you need the cohesive force of water. In plasma cosmology, gravity is the sand, and electromagnetism is the binding water, creating the delicate, filamentary structures we see. This stands in contrast to the standard model of cosmology, which relies heavily on the mysterious pull of dark matter to explain how galaxies hold together and move. In that view, the cosmic web is woven primarily by gravity's invisible hand. Plasma cosmology suggests the web itself is luminous and energetic, its filaments alive with current. For our plasma tunnels, this distinction is everything. If they are merely passive strands in a gravity-driven web, they are interesting scenery. But if they are active Birkeland currents on a cosmic scale, as Alfvén proposed, then they become dynamic pathways. They could be channels that not only guide matter, but also transport immense energy, spin up galaxies, and generate magnetic fields that span intergalactic space. This is not about proving one side wrong, but about exploring a compelling alternative that makes the existence of stable, powerful structures like plasma tunnels not just possible, but expected. It provides a physics-rich framework where these corridors are not anomalies, but fundamental features of an electric universe. But where does the immense energy to sustain such a cosmic highway come from? The answer lies in a violent, beautiful process that scientists call magnetic reconnection. It is the universe's ultimate power transformer, hidden within the flow of plasma itself. To understand it, think of a simple bar magnet. You know it has invisible lines of force looping from its north pole to its south pole. In the seething chaos of a plasma, these magnetic field lines are not static. They are frozen into the moving soup of charged particles, stretching, twisting, and braiding like strands of elastic. Sometimes, these strained lines from different magnetic domains are pushed together. They can snap, breaking their original connections, and then violently reconnect in a new configuration. This sudden rearrangement is not a gentle process. It is an explosive release of pent-up magnetic energy, converting it directly into blistering heat, light, and the acceleration of particles to nearly the speed of light. We witness this drama close to home. A solar flare is a titanic example of magnetic reconnection on the Sun's surface, unleashing in minutes more energy than all of humanity has ever consumed. Closer still, in the protective bubble of Earth's magnetosphere, reconnection events funnel solar energy into our atmosphere, directly powering the brilliant auroras we see. Now, scale this process up to the filament of a plasma tunnel stretching between galaxies. Within that vast, flowing river of magnetized plasma, countless microscopic reconnection events could be happening continuously. Each one acts like a tiny but potent power station, injecting energy into the filament, keeping it hot, keeping it structured, and preventing it from simply dissipating into the surrounding void. This constant, self-generated energy could be the secret to the tunnel's longevity. Instead of a structure that slowly fades, it becomes a self-organizing system, a stable pathway maintained by the very forces flowing through it. The reconnection process would regulate its energy, balance its magnetic fields, and allow it to persist not for millions but potentially for billions of years. These corridors are not passive pipes, they are living arteries powered from within by the cosmic fireworks of snapping magnetic fields. This constant flow of energy does more than just maintain the tunnel, it directs the traffic of creation itself. If these plasma filaments are the universe's superhighways, then the densest intersections, the galactic cloverleafs, become the sites where stars are born. The process is thought to be a kind of cosmic slingshot. Vast clouds of gas and dust, the raw material for new suns, are not scattered randomly. Instead, they are gathered and funneled along these powerful magnetic corridors. As the material flows, it can become pinched and compressed at certain points. Much like pinching a garden hose creates a pressurized jet. At these nodes, gravity finally gets its chance to act on an incredibly dense packet of matter. The pressure and density become so immense that the cloud can no longer support its own weight. It begins to collapse, spinning faster and heating up until, deep in its core, nuclear fusion ignites. A star is born. We see this blueprint written across our own galaxy. Look at a place like the Orion Nebula, a stellar nursery visible to the naked eye. Within its glowing clouds, telescopes reveal an intricate network of dark, dusty filaments. These are not mere shadows, they are the dense backbones of the nebula, the very structures along which gas is condensing into protostars. An even clearer example is the Musca molecular cloud, a dark streak against the southern Milky Way. Observations show it is not a simple blob, but a strikingly straight, needle-like filament, with newborn stars lined up along its spine like pearls on a string. This is the slingshot hypothesis in action, a visible snapshot of material flowing and concentrating along a magnetic highway to spark new light. It suggests that plasma tunnels are not just scenic routes through space, they are the delivery systems for the building blocks of galaxies. They guide the flow of cosmic ingredients, ensuring that stars form in organized patterns, not in chaotic bursts. The brilliant city of stars we call a galaxy may owe its very structure and continued growth to these hidden, magnetized rivers in the dark. This natural delivery system for star formation hints at an even grander purpose. If plasma tunnels can channel the ingredients for suns within a single galaxy, what might they accomplish between galaxies? Their potential as intergalactic transport routes is not science fiction, but a logical extension of their observed physics. These are not just structures, they are active conduits. Within their powerful magnetic grip, charged particles become trapped and accelerated, surfing the magnetic fields to incredible speeds. We already detect the end results of this process: cosmic rays, high-energy particles that bombard our planet from deep space. Many of these mysterious travelers could have been flung across the cosmos, not by random explosions, but by the focused slingshot effect of a plasma filament, a natural particle accelerator of unimaginable scale. But the cargo could be far more substantial than subatomic particles. Enormous, diffuse clouds of molecular gas, light years across, could be caught in this magnetic flow. Picture a vast, invisible river current gently pulling a giant raft of star-forming material. Over millions of years, such a cloud could be transported from a resource-rich region of the cosmic web into a relative void, seeding a new pocket of the universe with the potential for life. This raises a profound and tantalizing question. If raw matter and energy can be reliably shuttled along these stable pathways, what else might travel? Could the tunnels carry more than just physical cargo? In the dance of charged particles and shifting magnetic fields, information is constantly encoded. Patterns in energy fluctuations, waves of polarization, even complex magnetic signatures, these could all propagate down the length of a filament like a signal through a fiber optic cable. The universe may be whispering along these threads. And if information can flow, could these pathways over cosmic timescales influence the development of structure in a way that looks almost like a transmission? It moves us from thinking of the cosmos as a collection of isolated events to viewing it as a truly interconnected system, where a change in one galaxy might, through these luminous threads, eventually ripple to another. The idea that information can flow through these cosmic threads leads us to the edge of known physics and to a question that transforms a highway into a gateway. Could the very conditions that sustain a plasma tunnel also rip a hole in the fabric of our reality? This is the speculative leap where established science meets breathtaking possibility. Within the heart of these magnetized rivers, physics is pushed to its absolute limits. We have relativistic particles moving at a fraction of light speed, generating intense radiation. We have magnetic fields of such staggering strength they could warp the orbit of a planet. And according to Einstein's theory of general relativity, wherever you have immense energy and powerful magnetic fields, you also have a profound curvature of spacetime itself. The fabric of the universe in there is not flat and calm. It is twisted, strained, and turbulent. Now, layer on top of this several cutting-edge theories from the frontiers of physics. Concepts from string theory and certain models of quantum gravity suggest our universe may not have only the three spatial dimensions we experience. There could be additional, compactified dimensions curled up at scales far smaller than an atom, or even vast parallel brainworlds existing alongside our own. The mathematics of these theories often indicate that under conditions of extreme energy, these hidden dimensions could become accessible, or bridges between brains could form. This is where our plasma tunnel becomes more than a corridor. If such a structure, with its self-sustaining magnetic reconnection and titanic energies, were to achieve a specific, stable configuration, it might do more than bend spacetime. It could twist it into a knot so tight it connects to somewhere else. The tunnel would not be a passage through our universe, but a shortcut through the higher dimensional bulk, a true portal. What makes this more than pure fantasy is plasma's unique behavior. Plasma is not a passive substance. It is a highly organized collective state that can form self-contained structures like the durable filaments we see. Some physicists speculate that a plasma, with its ability to generate and sustain its own powerful magnetic fields, could theoretically create a stable sheath around such a dimensional rift. Picture it as a magnetic force field containing the violent physics of the gateway, making it traversable instead of destructive. It would be a natural, cosmological version of the ringed devices of science fiction, forged not by engineers, but by the fundamental forces of the cosmos over billions of years. This transforms our view entirely. The luminous threads of the cosmic web might be more than transportation routes for gas and stars. They could be the universe's own network of stargates, woven into its very architecture, waiting for a civilization with the understanding to find the map and read the coordinates. The possibility of a stable dimensional gateway hinges on a fabric of reality that is deeply, strangely interconnected. This brings us to one of the most baffling and profound mysteries in all of science: quantum entanglement. Here, two particles can become so deeply linked that measuring the state of one instantly determines the state of the other, no matter if they are across a lab or across the galaxy. This connection appears to happen faster than light, a phenomenon Einstein famously called spooky action at a distance. This is quantum non-locality, the idea that things can be correlated without any signal traveling between them through space. They seem to share a single existence, a single state that transcends physical separation. Now consider our vast plasma tunnels, structures that may physically connect distant regions of space. Could they be the cosmic scale manifestation of this same principle? Some theoretical physicists are exploring a radical synthesis that the fabric of spacetime we experience is not fundamental, but emerges from a deeper layer of reality, a vast, submicroscopic network of entangled quantum connections. In this view, every point in space is linked to every other point through this underlying web. The three-dimensional universe we see, with its galaxies and stars, is like the surface of a lake, while the quantum entanglement network is the complex, interconnected currents flowing beneath. If this is true, then what are the immense plasma filaments of the cosmic web? They might not just be structures in space, they could be where this hidden quantum network becomes visible, where it rises to the macroscopic scale. The intense magnetic fields and swirling energies within a plasma tunnel could amplify or stabilize these non-local connections, creating a physical bridge that mirrors the spooky link between particles. It is a staggering thought that the instantaneous bond between two electrons in a lab and the million-light-year-long luminous thread between two galaxy clusters might be different expressions of the same fundamental phenomenon. One operates in the quantum realm, the other in the cosmic, but both defy our classical intuition about distance and separation. This perspective suggests the tunnels are more than transportation routes. They could be the exposed nerves of the universe, the places where the underlying entangled reality pokes through into our own. Traveling such a corridor might not merely be a journey through space, but a passage through the deeper connective layer from which space itself is woven. The destination would not just be another location, but a point intrinsically linked to your origin by the universe's most fundamental glue. The universe's most violent engines may be the gatekeepers to its hidden pathways. At the heart of many galaxies, including our own Milky Way, lies a supermassive black hole, a gravitational pit so deep not even light can escape. But around some of these monsters, something extraordinary happens. Instead of a silent darkness, we see the brightest, most energetic objects in the cosmos, known as active galactic nuclei. These are not just black holes feeding, they are cosmic power plants, and their signature feature is a pair of jets. These jets are beams of matter and energy, shooting out from the poles of the black hole's accretion disk at nearly the speed of light, often stretching for hundreds of thousands of light years into intergalactic space. And what exactly are these jets made of? They are not solid, not gas as we know it. They are streams of magnetized plasma, channeled and focused by the black hole's immense spin and magnetic fields. In essence, they are the most intense, concentrated plasma tunnels imaginable, nature's own particle accelerators on a galactic scale. This gives us a critical piece of the puzzle. It shows that the same fundamental process that might create the diffuse filaments of the cosmic web can also be focused into a coherent, powerful beam by the most extreme gravity in the universe. The black hole acts as a natural nozzle, collimating the chaotic energy of infalling matter into a straight, stable tunnel of pure force. Now, let us take the speculation one step further. If a diffuse plasma filament in the void has the potential to stabilize a gateway, then what about the mouth of one of these relativistic jets, right at the event horizon of a supermassive black hole? The conditions there are unimaginable. You have gravity warping spacetime into a singularity. You have magnetic fields trillions of times stronger than Earth's. You have a maelstrom of plasma moving at relativistic speeds. According to the mathematics of general relativity, such a combination could twist the fabric of reality into a knot, potentially creating a wormhole, a shortcut through spacetime. But in most theories, such a wormhole would be violently unstable, collapsing instantly. This is where the unique properties of the plasma jet might intervene. The same powerful, organized magnetic fields that shape and contain the jet could, in theory, provide the exotic scaffolding needed to hold a wormhole throat open. The jet itself, a self-sustaining plasma tunnel, could be the traversable corridor leading to this gateway. It is a profound convergence where the universe's ultimate destroyer, a black hole, might also be the architect of its ultimate connection. The brightest beacons in the darkness could be more than lighthouses. They could be the very doorways woven into the luminous threads of the cosmic web, powered by the engines at the heart of galaxies. The most powerful doorways in the cosmos may have already been witnessed by human eyes. Our oldest stories are filled with visions of shimmering paths to other worlds. The Norse spoke of Bifrost, a burning rainbow bridge connecting our realm to Asgard. Ancient Hindu texts describe the Vaitana, a celestial river one must cross after death. Cultures across the globe, from the Aboriginal songlines to the Chinese tales of the Silver River, the Milky Way, share a common thread, a luminous highway in the heavens. What if these were not merely metaphors, but fragmented memories of real cosmic events? Modern plasma science offers a compelling lens. During periods of extreme solar activity, when our planet's magnetic shield was weaker or differently aligned, the sky would not have held the gentle auroral curtains we see today. It could have erupted. Intense geomagnetic storms, fueled by coronal mass ejections from the sun, might have generated plasma phenomena of terrifying scale and shape. Vast twisting columns of light, pulsating helical forms, and brilliant tunnel-like vortices could have dominated the ancient atmosphere. To a pre-scientific civilization, this would not look like a weather pattern. It would look like the fabric of the sky tearing open, revealing a radiant pathway to the domain of the gods. The descriptions match too well: the bridge of fire, the flowing river of light, the path that only the worthy or the dead could traverse. These stories could be humanity's first encounter with the physics of plasma portals, interpreted through the only framework available, mythology. The tales of gods descending on beams of light or heroes ascending to the stars along a luminous ladder take on a new, eerie resonance. It suggests a profound idea that the concept of a gateway between realms is not a modern science fiction invention, but an ancient, instinctual recognition of a cosmic truth witnessed in the sky. Our ancestors may have seen the local, atmospheric scale version of the very plasma tunnels we now theorize span the galaxy. They called it magic or divinity. We call it magnetohydrodynamics, but the awe-inspiring image at the heart of both understandings is strikingly the same: a glowing corridor through the void, a passage to somewhere else. These ancient skyward visions find a startling echo in our modern era. For decades, pilots, military personnel, and civilians have reported encounters with objects that defy all known laws of physics, phenomena we now call unidentified anomalous phenomena. Witnesses describe crafts that accelerate from a hover to hypersonic speeds in an instant, make right-angle turns without slowing, and move seamlessly from air to water to space. To conventional science, this is impossible, the stuff of fantasy. But if we apply the principles of plasma physics, a startling theoretical framework emerges. Imagine a craft enveloped in its own self-generated plasma sheath, a bubble of magnetized energy. This bubble could accomplish several revolutionary feats. First, it could radically reduce aerodynamic drag, effectively allowing the object to slip through the atmosphere like a hot knife through butter. Second, by manipulating the magnetic fields within that plasma, it could create localized distortions in gravity, a concept known as magnetogravitic propulsion. This would explain the sudden stops and starts, the lack of sonic booms, and the apparent defiance of inertia. The craft wouldn't be pushing against the air, it would be gently or violently bending the fabric of space-time immediately around it. But the most profound possibility lies in where such a vehicle might be going. If these objects possess a technology that masters plasma and magnetic fields, they might not be navigating through space as we understand it. They could be navigating the space we have been discussing, the cosmic infrastructure itself. A craft encased in a stable plasma bubble could, in theory, enter one of these natural plasma filaments, these vast magnetic flux tubes that thread the galaxy. Inside, it could be carried along by the current or use the tunnel's own magnetic field as a guide rail, traveling immense distances with minimal energy expenditure. The sudden appearances and disappearances reported in so many encounters might not be cloaking devices, but entries and exits from this hidden network. A flash of light could be the signature of a vehicle plunging into or emerging from a localized plasma conduit, a man-made or perhaps other-made utilization of the universe's natural transportation grid. This shifts the UAP discussion from mere extraterrestrial visitation to something even more paradigm-shattering. It suggests that some of these objects may not be coming from another planet in our solar system, but from another node in a cosmic web we are only beginning to map. They might be using the shortcuts woven into reality itself, turning the luminous threads of the cosmic web into their interstellar highways. The theories of cosmic gateways find their first real tests not in distant galaxies, but in university laboratories. Here, scientists are using some of the most powerful tools on Earth to create miniature versions of these plasma tunnels, aiming to unlock the secrets of their cosmic cousins. They employ colossal lasers like the National Ignition Facility, or sophisticated machines called plasma pinchers and Z-pinchers. These devices generate brief, intense bursts of energy that can turn a tiny amount of gas into a seething, magnetized plasma, forcing it to self-organize into straight, stable filaments. For a fraction of a second, they birth a star in a bottle, or more accurately, a thread of the cosmic web in a vacuum chamber. The goal is not to open a portal, but to understand the fundamental rules. They watch how these lab-scale filaments form, how long they last, and most importantly, how they interact with magnetic fields. They can induce magnetic reconnection events, creating miniature solar flares and observing how the filament responds, whether it dissipates or finds a new, stable equilibrium. It is like learning the properties of steel by studying a paperclip before attempting to engineer a suspension bridge. These experiments have already yielded critical insights. They show that under the right conditions, plasma filaments can be incredibly robust and self-contained, maintaining their structure far longer than the raw energy input would suggest. They demonstrate how magnetic fields can act like a flexible skeleton, holding the energetic plasma together against forces that want to make it explode outward. This laboratory evidence provides a crucial foundation, suggesting that the vast filaments we infer in space are not only possible, but likely possess an inherent stability we are only beginning to quantify. Each successful experiment is a small vote of confidence from the laws of physics, hinting that the universe might indeed be woven from threads that are built to last. Even the most stable cosmic gateway would be a passage through hell. The environment inside a theoretical traversable plasma tunnel is not a serene, star-lit corridor. It is a maelstrom of forces that would obliterate any known material in an instant. Temperatures would be measured in millions of degrees hotter than the core of our sun. The magnetic pressures would be so immense they could crush a planet's core into a diamond, then crush the diamond into something we have no name for. And saturating this entire space would be a torrent of high-energy radiation, a lethal soup of gamma rays and cosmic particles that would shred organic molecules and scramble any electronics not specifically hardened against it. This is not a highway you could simply fly a ship down. It is a river of raw stellar fury contained and channeled by physics we can barely replicate. The sheer energy density is the first and greatest barrier. To survive, a vessel would need a shield that does not yet exist, one capable of reflecting or absorbing that unimaginable heat and radiation without itself being vaporized. Our most advanced heat shields, like those on spacecraft re-entering Earth's atmosphere, are designed for mere thousands of degrees, and they still burn away as a sacrificial layer. For millions of degrees, we have no material solution. This pushes the idea into the realm of force fields, a staple of science fiction that remains firmly in the theoretical domain. The concept would require generating a self-sustaining magnetic bubble or plasma sheath so powerful it could actively push the tunnel's own seething energy away, creating a pocket of calm within the storm. The energy required to maintain such a field for even a second would dwarf the total output of our global civilization, and then there is the problem of navigation. Inside that chaotic magnetic flux, compasses would spin uselessly, light would be bent and scattered. The very concept of straight ahead might lose meaning in the twisted topology. Guiding a craft would be less like driving a car and more like trying to steer a raft through the heart of a hurricane while blindfolded. These are not minor engineering puzzles. They represent fundamental gaps in our understanding of physics, material science, and energy generation. The obstacles are so profound that they force a humbling perspective. The universe may have woven these threads into its fabric, but it did not necessarily weave them for us. They might be natural features like the fiery core of a planet or the crushing depths of a gas giant's atmosphere that are intrinsically hostile to complex matter and life as we know it. Their purpose could be purely cosmological, to structure galaxies and birth stars, not to serve as transit routes. Yet, this grounding in reality does not extinguish the wonder. It reframes it. The challenge itself becomes a compass pointing toward the frontiers of human knowledge. The quest to understand how one might, in theory, traverse such a place forces us to ask new questions about energy, about spacetime, about the very limits of what is possible. It tells us that if such pathways are ever to be used, it will not be with technology that is a simple extension of our own. It will require a leap as profound as the one from sailing ships to interstellar travel, a mastery of the cosmos that transforms us from passengers within the universe to active navigators of its deepest architecture. The crushing energies inside a plasma tunnel are not the only barrier to travel. They are also the key to its greatest potential. Einstein's theory of relativity gives us a profound and strange gift when dealing with such extremes, the bending of time itself. Within one of these magnetized corridors, matter isn't just flowing. It is being accelerated by those immense magnetic fields to a significant fraction of the speed of light. And at those velocities, relativity isn't a subtle effect. It is the dominant force shaping reality. Time dilation becomes unavoidable. For a hypothetical traveler moving at such incredible speed, time would pass more slowly relative to the outside universe. A clock on their ship would tick at a leisurely pace, while clocks on Earth or on the planets at either end of the tunnel would race ahead. This transforms the entire concept of distance. Let us say a plasma tunnel connects our solar system to a star system 10,000 light-years away. From the perspective of someone back on Earth watching a ship enter that tunnel, the journey would appear to take well over 10,000 years. It would be a voyage for the ages, but for the crew inside the ship surfing that relativistic current, the story is utterly different. Depending on how close to light speed they travel, their subjective experience of the journey could be compressed into just a few decades or even a handful of years. They would age only that much. This is the twin paradox of relativity brought to life on a cosmic scale. One twin boards a ship and rides the plasma highway, the other stays home. When the traveling twin returns after what felt like a 20-year mission, they step out to find their sibling and perhaps their entire civilization millennia older. The tunnel, therefore, offers a double shortcut. First, it might provide a physical shortcut through space, a warped geometry that reduces the actual distance. Second, and just as crucially, it provides a temporal shortcut for the traveler, compressing the subjective time required to cover that distance. Combined, these effects shatter the traditional limitations of interstellar travel. The galaxy, which seems impossibly vast and lonely when limited by conventional rocket propulsion, suddenly becomes navigable within a single human lifetime. You could, in theory, reach the galactic core, witness the alien skies of countless worlds, and return within your own biological span, even if the calendar back home has advanced by tens of thousands of years. This isn't merely faster travel, it is a redefinition of what travel means. It turns a voyage across the stars from a one-way, multi-generational exile into a personal expedition. The plasma tunnel becomes more than a road. It is a time machine for its passengers, offering them the stars while demanding only a chapter of their lives. This temporal shortcut hints at a deeper connection, one that transcends matter and energy. The most valuable cargo a plasma tunnel might carry is not physical at all, but pure information. To grasp this, we must confront one of physics' great puzzles, the black hole information paradox. In simple terms, if you throw an encyclopedia into a black hole, all that complex information about words and pages seems to vanish forever, swallowed by the singularity. This violates a fundamental quantum law that information can never be truly destroyed. To resolve this, theorists like Leonard Susskind proposed the holographic principle. It suggests all the information that makes up our three-dimensional universe, every star, every planet, every one of us, might not be stored within the volume of space, but on its two-dimensional boundary like a cosmic DVD. The universe we experience would then be a holographic projection from that surface. If that sounds strange, consider a more familiar example. The information on your credit card is not stored throughout the plastic. It is encoded on the magnetic stripe along its edge. The holographic principle says reality itself might work in a similar, mind-bending way. Now, where do our plasma tunnels fit into this? If the universe is a projection, it needs a projector. It needs circuits to translate the data from the boundary into the rich, three-dimensional world we see. Some physicists speculate that the cosmic web's filaments, those vast plasma tunnels, could be that very circuitry. They are the conductive wires woven through the cosmic hologram, carrying the information that structures galaxies and dictates the laws of physics in their vicinity. They are not just transporting gas, they might be transmitting the cosmic code itself. This shifts their purpose from mere transportation to communication. A fluctuation in the magnetic field of one filament could, in theory, induce a correlated fluctuation in another, connected filament instantly across any distance. This is not faster than light travel, it is a non-local connection, a cosmic version of quantum entanglement writ large. The tunnels become the nervous system of the universe, allowing different regions to stay in sync, to share data about their state and evolution. This leads to a speculation that borders on philosophy. If the cosmos is interconnected by an active network of information-carrying filaments, could it possess a form of awareness? Not a human-like consciousness, but a vast, slow, cosmological process of self-regulation and information integration. The plasma tunnels would be the axons and dendrites, with galaxy clusters acting as neural nodes. A thought in such a system might take 1 billion years to form, a ripple of magnetic realignment that restructures a spiral arm. While this idea of a cosmic mind is far beyond current science, the underlying mechanics are not. The possibility that these luminous threads form a stable, universal network for transmitting information is a serious theoretical extension of the holographic principle. It means that when we finally map the magnetic fields of the cosmic web in detail, we might not just be charting geography. We could be learning to read the universe's own source code, transmitted along rivers of fire since the dawn of time. The universe's hidden wiring might also hold the answer to its greatest missing pieces. For decades, astronomers have faced two colossal mysteries: dark matter and dark energy. We see their effects everywhere, but we have never directly detected what they are. Dark matter's invisible gravity holds galaxies together, preventing them from flying apart as they spin. Dark energy is the mysterious force causing the entire cosmos to expand at an accelerating rate. They are the dominant ingredients of reality, making up over 95% of everything, yet they remain ghostly abstractions. But what if these ghosts are not new, exotic substances? What if they are manifestations of a force we already know, electromagnetism, operating on a scale we are only beginning to map? This is where plasma cosmology offers a radical reinterpretation. In this view, the vast seas of diffuse plasma that fill intergalactic space are not inert. They are alive with electric currents and magnetic fields. The collective electromagnetic effects of this pervasive, magnetized plasma could generate the precise kind of extra-gravitational pull we attribute to dark matter. It would not be an invisible particle, but the invisible push and pull of cosmic-scale magnetic forces shaping the motion of stars. Think of a galaxy not as an island in an empty void, but as a dense knot within a vast, energized circuit. The long-range magnetic fields from the surrounding plasma filaments could act like cosmic hands, gently gripping the galaxy's outskirts and spinning them faster than visible matter alone would allow. This would perfectly explain the rotation curves of galaxies without needing to invent a new form of matter. The dark matter halo we infer might actually be a luminous electromagnetic halo, a glow of current we have not yet learned to see. Now extend this idea to the largest scale of all, the accelerating expansion of the universe. If these plasma filaments and their magnetic fields are everywhere, woven through the cosmic web, they carry immense energy. This energy, inherent to the fabric of space itself, could be the driver behind what we call dark energy. It would not be a mysterious anti-gravity force, but a natural consequence of the universe's own electromagnetic infrastructure, a pressure exerted by the network of currents that built it. In this framework, our plasma tunnels become far more than potential passageways. They are the active components of the universe's engine room. The same currents that might stabilize a gateway also dictate the fate of galaxies and steer the expansion of all reality. This connects the speculative wonder of interstellar travel to the most fundamental questions in cosmology. Are we on the verge of a unification where the luminous threads of the cosmic web explain not only how the universe is structured, but why it behaves the way it does? The search to understand these tunnels then becomes a search for the true nature of reality itself, a journey to find the light in the darkness. The universe may have built its gateways, but how would we ever find the door? The challenge is that a stable plasma portal would not hang a sign in the void. Its signature would be written in a language of extreme physics, a subtle combination of signals we must learn to read. The first clue would likely be an anomaly in high-energy radiation. Imagine a point in deep space, far from any known black hole or colliding neutron stars, that suddenly erupts in a burst of gamma rays. But instead of fading quickly, this burst shows a strange, sustained flicker, a rhythmic pulsing that doesn't match any known celestial object. This could be the signature of magnetic reconnection events happening on a colossal, structured scale within a tunnel, like a lighthouse beacon powered by snapping spacetime. Equally telling would be the polarization of light coming from such a region. Polarization refers to the orientation of light waves as they travel. The intense, ordered magnetic fields within a plasma portal would forcefully align any light passing through or emanating from it, creating a distinct, swirling pattern of polarization across different frequencies. It would be like seeing a cosmic fingerprint of immense magnetic structure where none should exist. Another signature might be written in the paths of cosmic rays. These high-energy particles are already mysterious, but if they were being funneled and accelerated through a specific, narrow corridor of space, we might detect them arriving from a very precise direction in the sky with energies that follow a unique pattern, a beam of ultra-high-energy particles pointing like an arrow to their source. Perhaps the most elegant signature would be a distortion in gravity itself. A massive, energy-dense plasma tunnel would warp space-time around it. If such a tunnel lay between us and a distant galaxy, its gravity would act as a lens, bending and magnifying the galaxy's light. But the distortion pattern would be peculiar, not the smooth arc of a galaxy cluster's lens, but a strange, elongated or filamentary smear, as if the light were being bent along a narrow, invisible tube. Thankfully, our tools for this cosmic detective work are arriving. Radio telescopes like the upcoming Square Kilometre Array will map the universe's magnetic fields with unprecedented detail, potentially revealing the coherent tube-like structures of these filaments. Gravitational wave observatories, such as the future space-based LISA mission, could detect the ripples in spacetime from massive objects moving within or through such a corridor, a vibration unlike any binary black hole merger. Even existing telescopes hunting for dark matter by looking for unexplained gamma-ray lines might stumble upon the energetic exhaust of a stable portal. The search has moved from pure speculation to a data mining challenge. We are no longer just asking if such things could exist. We are building the instruments that could find their fingerprints in the noise of the cosmos, turning a breathtaking idea into a testable hypothesis waiting in the data stream. The cosmic silence is one of our deepest existential puzzles. If the universe is so vast and ancient with billions of potentially habitable worlds, why have we heard nothing, seen nothing? This is the heart of the Fermi paradox, the question, where is everybody? The unsettling answer might be that something stops civilizations from reaching the stars, a barrier so absolute it's called the Great Filter. Perhaps it's not a plague or nuclear war or an asteroid. Perhaps the filter is a highway. Our plasma tunnels, those magnificent structures woven through the galaxy, could represent the ultimate test. They offer the promise of the stars, a network of shortcuts that makes the galaxy accessible. But the price of admission might be annihilation. Think of the physics we just explored, the seething million-degree plasma, the magnetic fields that can crush planets, the torrents of lethal radiation. A civilization that discovers these corridors would face a terrible temptation. The shortcut is right there, glowing in their telescopes, a path mapped by the universe itself. The urge to take that first step, to build a ship and enter the current, would be overwhelming. It would be the defining moment of their history, and it could be their last. Their technology, no matter how advanced, might be insufficient. A miscalculation in magnetic shielding, a misjudgment of the energy flux, and their vessel, their entire expedition, would be vaporized in a microsecond, lost without a trace. The tunnel would not be malevolent. It would simply be what it is, a natural feature of the cosmos, as deadly as the heart of a star. In this scenario, the galaxy is not empty of life, but littered with the silent graves of those who tried to cross the bridge before they were ready. The filter isn't about surviving your own planet, it's about surviving your ambition to leave it. The silence we hear is the echo of that failure, repeated on a million worlds. But there is a second, even more profound possibility. What if mastering the plasma tunnel isn't the filter that destroys, but the filter that transforms? Perhaps no civilization has yet passed the test. The challenge of containing those energies, of navigating non-local space, of bending time without being torn apart, might be so monumental that it represents an evolutionary leap in understanding. It's not a test of engineering alone, but of consciousness, of a species' ability to think in terms of interconnected realities and higher dimensions. Passing through the gateway might require a unification of physics and philosophy we haven't yet imagined. Those who succeed don't just gain a new mode of travel, they undergo a metamorphosis. They cease to be a planetary species and become something else entirely, a galactic or even a multidimensional civilization. Their concerns, their communications, their very presence might become undetectable to those of us still on the outside, still bound by slower-than-light radio waves and chemical rockets. They would move in the layers beneath reality, in the quantum connections and magnetic flows, as invisible to us as a submarine is to a stone on the ocean floor. The cosmic silence, then, isn't a sign of failure or emptiness. It is the quiet hum of a universe where the truly advanced have graduated to a different classroom, using a network we can see but cannot yet enter. The great filter is not a wall but a door, and the key is understanding that the universe's most beautiful structures are also its most demanding teachers. Mastering the cosmic network would force a choice of unimaginable consequence. If these plasma tunnels are indeed the universe's foundational architecture, then accessing them is not merely a technological achievement, it is an act of profound intervention. We would be tampering with the very wiring of reality, the currents that birth stars and guide galaxies. The ethical weight of that is staggering. Do we have the right to reroute a current that has flowed for billions of years, potentially starving a distant nebula of the material it needs to create new solar systems? Could our passage through a tunnel, like a ship disturbing a riverbed, create destructive turbulence in the magnetic fields of a nearby inhabited world? The responsibility would extend beyond our own survival to a form of cosmic stewardship, requiring a wisdom we have yet to demonstrate on our own planet. This leads directly to the question of control. If these pathways are real and usable, they become the ultimate strategic resource, the choke points of the galaxy. The civilization that first maps and commands them holds the keys to the cosmos. History on Earth is a relentless lesson in how such power corrupts. Would humanity use this network for exploration and connection, or for dominance and exclusion? The very structure might prevent monopoly, however. A network woven through the fabric of space likely cannot be owned or blockaded in any conventional sense. Its entrances might shift with stellar movements or require a synchronization with local magnetic fields that is as much an art as a science. Control may not mean planting a flag, but possessing the understanding to navigate the currents, a knowledge that cannot be easily weaponized or hoarded. This redefines humanity's place in the cosmos. We would no longer be lonely inhabitants of a tiny rock, peering out at an unreachable vastness. We would become participants in a dynamic, interconnected system. Contact, if it happens, would not be a ship landing in a desert. It would be an encounter within the flow itself, a meeting in the conduit between worlds. The potential for conflict is obvious, a territorial dispute over a corridor of twisted spacetime. But the nature of the network suggests another possibility: unification. To travel the tunnels is to submit to their physics, to operate within rules set by the universe itself. It demands a harmony with forces that care nothing for national borders or ideological differences. A common framework for navigation and safety would be an immediate necessity, perhaps forging the first truly universal laws. The greatest philosophical shift, however, lies in what we might learn. Accessing these pathways means we are no longer just observing the universe from the outside. We are probing its internal mechanics. We are reading the source code. The knowledge gained could answer our oldest questions about existence, time, and consciousness, but it could also reveal truths we are not prepared to accept. What if we discover the network has a purpose beyond our comprehension, or that we are not the intended users? The journey through a plasma tunnel might be more than a voyage through space. It could be an initiation into a reality far stranger and more magnificent than we ever dreamed, demanding from us not just new engines, but a new humility. The next chapter in this cosmic detective story is already being written. Our quest to understand plasma tunnels will not rely on a single telescope or satellite, but on a fleet of specialized missions, each designed to probe a different piece of this magnificent puzzle. Some of the most crucial voyages are headed not into the deep void, but toward the heart of our own solar system. NASA Parker Solar Probe is a technological marvel, a spacecraft built to dive repeatedly into the sun's corona, the seething atmosphere of plasma that surrounds our star. It flies through the birthplace of the solar wind, tasting the very substance of those fundamental Birkeland currents that shape our local space. Each pass provides data on how plasma behaves under extreme heat and magnetism, giving us the rulebook for its behavior on larger scales. Meanwhile, at the giant planet Jupiter, the European Space Agency's JUICE mission will spend years immersed in one of the most powerful magnetic environments we can reach. Jupiter's magnetosphere is a miniature cosmos of plasma dynamics, a laboratory where we can study how charged particles are accelerated, trapped, and funneled along magnetic field lines on a planetary scale. The lessons learned here in this turbulent realm of radiation and auroras are directly applicable to the vast magnetized filaments we suspect connect galaxies. These missions are not looking for portals, they are performing fundamental physics, building our understanding of plasma one violent, beautiful environment at a time. Yet we cannot send a probe to a filament 10 million light-years away. To bridge that gap, we turn to the silent power of supercomputers. Advanced simulations are the virtual telescopes for this new frontier. Scientists feed the known laws of magnetohydrodynamics, the marriage of magnetism and fluid motion, into these digital universes. They then set the initial conditions matching the early cosmos and let the simulation run. What emerges time and again is a cosmic web, a network of filaments that looks hauntingly like the one we observe. These simulations allow us to rewind and fast forward, to test what happens when we tweak the strength of magnetic fields or the density of plasma. We can watch virtual reconnection events spark and see if they stabilize or destroy a filament. We can inject a packet of energy and see how it propagates, searching for signatures that a real telescope might one day detect. It is a process of cosmic reverse engineering, using the universe's own blueprints to understand how it assembled itself. Without these digital laboratories, the grand ideas of plasma tunnels and non-local networks would remain pure speculation. They provide the crucial link between theory and observable reality. The ultimate goal is a unified map, a synthesis of data from across the spectrum of science. This search cannot belong to astrophysics alone. It demands a convergence of disciplines that rarely speak the same language. Plasma physicists from fusion labs must share their insights on containment and stability with cosmologists mapping the large-scale structure. Experts in quantum gravity must help interpret what extreme spacetime curvature within a filament might mean for information theory. Even laboratory scientists creating tiny plasma pinches contribute vital data on how these structures self-organize. The evidence we seek will be a mosaic, a pattern recognized only when all the pieces are laid side by side. A strange polarization pattern in radio telescope data might find its explanation in a supercomputer simulation of magnetic turbulence. An anomalous cosmic ray detection could be cross-referenced with a new map of intergalactic magnetic fields from a space observatory. This multidisciplinary hunt is the hallmark of a science on the verge of a paradigm shift. We are no longer just cataloging stars, we are learning to read the energetic language of the cosmos itself, a language spoken in the flow of charged particles and the geometry of twisted spacetime. The answers are out there, written in the light of the first stars and the magnetic echo of the Big Bang, waiting for us to become fluent enough to understand. The line between a scientific theory and a science fiction dream can be surprisingly thin. On one side, we have solid, observable reality. We have mapped the cosmic web's filamentary structures with telescopes. We have flown spacecraft through Earth's own Birkeland currents. We have watched magnetic reconnection unleash solar flares and power the aurora. These are not guesses, they are measured phenomena, the bedrock facts upon which this entire idea is built. They tell us the universe is woven with threads of magnetized plasma, and that these threads are dynamic, powerful, and fundamental to cosmic structure. This is the science fact, a foundation sturdy enough to build upon. Then we step across the line into the realm of informed, thrilling speculation. The notion that one of these filaments could be a traversable portal, a stable gateway to another reality or a distant point in our own, is not yet science. It is a hypothesis, a glorious what-if built by extending known physics into extreme and uncharted territories. It takes the proven stability of plasma filaments and asks, what is the absolute limit of that stability? It takes the proven warping of spacetime by energy and asks, could that warp become a shortcut? These questions are not wild fantasy, they are guided extrapolations, but they remain unproven. They are the hope built on a foundation of hype, and it is crucial to know the difference. This distinction, however, is not a wall, it is a frontier. The history of science is the story of that frontier moving. Time and again, yesterday's science fiction becomes today's laboratory fact. The concept of communication satellites was pure fiction until the physics of orbital mechanics made it inevitable. The idea of humans walking on the moon was a dream for millennia before it became a historical headline. The line is always blurring, pushed back by curiosity and evidence. So while we must hold our critical thinking close, questioning every assumption, we must also protect that sense of wonder. It is the wonder that asks the next question, that funds the next telescope, that inspires the next generation to run the simulation one more time. The speculative leap towards plasma portals is not a failure of rigor, it is an essential engine of discovery. It gives our exploration of the cosmic web a destination, a purpose beyond mere cataloging. It challenges us to look at the data and ask not just what is, but what could be. The greatest scientific breakthroughs often begin not with an answer, but with a beautifully dangerous question whispered from the very edge of the possible. The cosmos is not a collection of isolated islands, but a single, breathing tapestry. Woven through its vast darkness are luminous threads of plasma, the fundamental architecture of everything we see. These are not passive decorations, but active, dynamic forces. They guide the birth of stars in stellar nurseries, channel immense energies between galaxies, and sculpt the largest patterns in existence, the cosmic web itself. This network is the universe's circulatory system, its nervous system, and perhaps its very skeleton. We have moved from seeing space as an empty stage to recognizing it as a vibrant, interconnected medium, humming with magnetic energy and alive with current. The evidence surrounds us, from the aurora over our heads to the filamentary structures mapped between distant galaxy clusters. This is the established, observable truth, a revolution in understanding that redefines our place in the cosmos. Yet the deepest implications shimmer just beyond the edge of our instruments. If these filaments are the universe's foundational wiring, then their purpose may extend far beyond the physics we currently comprehend. They could be more than cosmic plumbing, more than highways for gas and energy. The most compelling speculation is that they are the threads connecting different layers of reality itself. Think of a spider's web glistening with morning dew. From our perspective, we see the intricate two-dimensional pattern. but to a tiny insect, each strand is a tunnel, a conduit that exists in its own right, leading to different parts of the web's structure. Our plasma tunnels might be similar, existing within our three-dimensional space, but also serving as bridges to realms or dimensions that are otherwise folded away, inaccessible. They are not rips or tears, but stable features integrated into the cosmos's blueprint. This suggests a cosmos of breathtaking intricacy, a kind of cosmic internet where information, energy, and perhaps even consciousness flow along predetermined pathways. The universe would be a single, coherent entity, not a random scattering of objects. A change in one galaxy, a burst of creative energy, or a cataclysmic event might not be an isolated incident. Its signature could propagate along these luminous threads, influencing the development of structure elsewhere over epochs of time. It is a vision of a truly living universe where connectivity is not a metaphor, but a physical law written in magnetic fields and searing plasma. Our search for meaning in the stars then takes on a new dimension. We are not just mapping locations, we are learning to listen to the conversations flowing through the universe's own network, waiting to hear what the cosmos has been saying all along. From the shimmering aurora over our heads to the vast, invisible rivers of power connecting galaxies, this journey reveals a cosmos far stranger than we once believed. We began with a simple earthly phenomenon, a curtain of light dancing in the polar sky, and traced its origins to a universal force. That force, the flow of magnetized plasma, appears to be the universe's master architect, weaving the very fabric of the cosmic web. These luminous filaments are more than beautiful structures. They are active conduits of energy, potential shapers of stars, and perhaps the stable skeletons of gateways to realms beyond our own. We have moved from observation to speculation, from the solid ground of measured Birkeland currents to the thrilling precipice of dimensional shortcuts and cosmic minds. Each step was built upon real science, yet each leap forward asks us to reimagine reality itself. The line between what we know and what we dream is precisely where discovery thrives. The universe has laid out its blueprint in threads of fire, and we are only now learning to see the pattern. Our greatest adventure is no longer a voyage to a distant planet, but a journey of the mind, a quest to decipher the hidden language of magnetic fields and quantum connections. Every new telescope, every advanced simulation brings us closer to reading that cosmic code. So keep looking up, not just at the stars, but at the spaces between them. In that darkness, the true architecture of reality glows with a faint, ancient light waiting to be understood. What do you think lies at the end of these cosmic threads? Share your boldest theories in the comments below, and if you want to join us for more deep dives into the universe's greatest mysteries, be sure to subscribe. The map of the cosmos is being redrawn, and the next chapter is ours to write.